Impacts and Collisions 2017, question 5b. A small sphere, smooth sphere P of mass 3m collides obliquely with a small smooth sphere Q of mass 7m, which is at rest. Before the collision, the velocity of P makes an angle alpha with the line joining the centers of the spheres. After the collision, the speed of Q is v, and the coefficient of restitution between the spheres is 2/7. Find in terms of v and alpha the speed of P before the collision, and if alpha is 30 degrees, find the angle to which the direction of motion of P is deflected as a result of the collision. Okay, let's have a look at what's going on with P. P, just move up a little bit. P, my J direction and my I direction, and you can see alpha is opposite J, so that's the sine part, and for I it's adjacent. So we have speed of u, we told speed of u. We're not given the speed, so we'll call it u. So u cos alpha times I plus u sine alpha j is P. Q is at rest, so it's 0I plus 0j. That's before. What about afterwards? But we know here that afterwards, the only thing that changes is the I, the j doesn't change. So for P, we're going to have V1 in the I direction, we don't know. The j direction is not going to change. And in the Q, sorry, should be P for Q, the j direction is not changing. And we have a velocity for I, we'll call it V2. So my principle of conservation of momentum M1 U1, I'll make them smaller, plus M2 U2 is equal to M1 V1 plus M2 V2. So we fill our information in. What are our masses? 3m and 7m. So 3m U1 plus 7m U2. And we have our U, we have this U2 is actually 0, is equal to, the first mass is 3m by V1, and the second mass is 7m by V2. So simplifying this down, we can cancel our m's, and we get 3u1 is equal to 3v1 plus 7v2. Using Newton's experimental law, we know that v1 minus v2 over u1 minus u2 is equal to minus e. So my v1 minus v2 is equal to minus e, which they give us e, don't they? They told us 2/7. It's equal to minus 2/7. And I'm going to bring this u1 minus u2 up. And I actually have my u1, I should have filled it in here. My u1 is u cos alpha. And my u2 was 0. So I get 7v1 minus 7v2 is equal to minus 2u cos alpha. And I have, do I have a 7? I have a 7v2 here. So 3v1 plus 7v2 is equal to 3, and my u was u cos alpha. So if I combine these two, I'm going to get 10v1 is equal to just u cos alpha in this case. So v1 is equal to u cos alpha over 10. Now what's V2 equal to? We don't have V2 on its own. We have 7V2, but I could use this one. This one, we have 7V2 is equal to 3U cos alpha minus 3V1. So 7V2 is equal to 3U cos alpha minus 3U cos alpha over 10. Over 10, not by 10. So we have 7V2. Simplify this into a single fraction. We have 30 cos alpha on the left over 10. So that's 27 U cos alpha over 10. And if I divide by 7, V2 is 27 U cos alpha over 7 times 10, which is 70. Now what were we asked for here? We were asked for find in terms of V and alpha the speed of P before the collision. So we need U. So let's find U then. So we have U is equal to 10V1 in this case. U is equal to 10 times V1 over cos alpha. So 10 times V1 is 10 U cos alpha over 10. We read the question carefully. In terms of V and A, and we were told that V is the speed of Q, so that's my V2, so I actually need it in terms of V2. So important to read the question carefully. So let's just look at U in terms of V2. So 70 times V2 is equal to 27 U cos alpha. So 70 V2 is equal to over 27 cos alpha is equal to U. That's what they're looking for in part 1. If alpha is 30, find the angle through which the direction of motion of P is deflected as a result of the collision. Okay, so alpha is 30. So it will help if I write down what's happening with P. U cos alpha plus U sine alpha times J. So the U sine alpha times J is not changing. And I have this new V1. So I have U cos alpha over 10 in the I direction plus U sine alpha in the J direction. That's P after. So we're looking for the angle of deflection. So cos alpha is root 3. We're told alpha is 30. So the cos of 30 is root 3 over 2, and the sine of 30 is a half. Now U is positive, so we can kind of cancel this. We'll leave the U in for now. If we imagine, well, let's simplify this down. U by root 3 over 2 over 10 is going to be root 3 over 20 in the I direction, and then we're going to have U by a half in the J direction. So these are both positive. So I'm looking at, here's my point of deflection, and we're going in a positive I, positive J direction. And let's call this angle A. So my I direction is root 3 over 20. And if we imagine from the original collision that we had it coming in like this to this point here, where this angle is alpha, which we were told was 30, and it's getting, say, moved off in that direction. So we're now in this triangle here where the 30 degrees is in here. So this part of the angle is 30. So we're going to need to get alpha and take 30 away from it. So I've got root 3 over 20 and I've got a 1 over 2. So the tan of A is equal to 1 over 2 divided by root 3 over 20, which is going to give me 1 over 2 times 20 over root 3, which is not 30, 10 over root 3. So that's going to give me 10 over root 3. So the inverse tan of 10 over root 3, what's that going to give me? It's going to give me 80.17. So my angle then, my angle of deflection from this point, if I take away the 30, I'm going to get what's in there. So what way was the question phrased? The direction of the motion of P is deflected 50.17 degrees is the answer.